Hi, my name is Bethany Shire and I am a current chemistry DPhil student at the University of Oxford. So today I'm going to tell you a little bit about my background and what I'm currently researching. So I'm originally from Derbyshire, and for my A-levels I decided to study biology, chemistry, maths and further maths. I studied biology because that was my favourite subject at high school and I thought that that's what I was going to want to do at university. But while I was at college I had a really amazing teacher in chemistry which made me realise that actually organic chemistry was what I was really interested in. So I changed my mind and decided to study chemistry at Undergraduate. So for my undergraduate I did a 4-year integrated master's course at the University of Oxford at Pembroke College. And what that meant was that I basically spent the first 3 years doing lectures, practicals and some tutorials. And then in the 4th year I got the opportunity to join a proper research group and do a long project doing my own research for the first time. And this was by far my favourite part of the undergraduate course, and I really enjoyed the experience of being part of a lab group and getting to do my own research, so I knew that I wanted to stay on and do a PhD. So I stayed on for my PhD with the group that I was in for my Masters, which is the Ed Anderson group, and I'm now a 2nd year DPhil student. PhD life is kind of different to undergraduate life. So I'm part of a doctoral training centre, which means that I'm funded, so my university fees are paid, and also I receive a stipend to help with living costs. One of the good things about doing a PhD is you're getting to do brand new research, so there's a good chance no one has ever done the reactions before that you're doing, so you really are the expert in what it is that you're researching. Another great thing about PhDs is you get the opportunity to travel for conferences. So in the spring of 2019 I had the opportunity to go to Grasmere in the Lake District for a conference. And while I was there I got to hear some world-leading chemists talk, I got an opportunity to present some of my own work, and during our free time we were allowed to go and explore the Lake District. So in terms of what I'm doing for my PhD, in a nutshell I'm trying to improve medicines with carbon propellers. So propelling is a kind of weird looking molecule. It's made up of 5 carbon atoms and it's called propelling because it kind of looks like a propeller. But other than it looking kind of weird, why should we care about propelling? Well, when we're developing some kind of medicinal drug, quite a lot of the time what you'd want it to be doing is binding to the active site of an enzyme. And the active site of an enzyme is a 3-dimensional space. But a problem with a lot of medicines is that the drug molecule itself can be kind of flat. So although it might be able to bind to the active site, it's not necessarily binding as well as it could do. So, in order to combat this, one solution could be to add more 3-dimensional components to the drug molecule. For example, if you take this representative drug molecule on the left, it's kind of flat. So this is where propelling could come in. We can take out one of the flat bits and instead react some building blocks with propelling and create a drug molecule that has more 3-dimensional character. And that can mean better solubility, it could mean that it's metabolized slower so it hangs around in your body for longer and therefore it has longer to do whatever it is you wanted the drug to do. So my PhD is all about trying to find new reactions with propelling. So new ways that we could put it into drug molecules when we're trying to develop it to see if it does give a benefit. And it's all about trying to increase the toolkit so that propelling is easier to use when developing medicines. So thank you for listening, and if you want to find out more about work at the department, you can visit the department website.